Hi everybody, it's Miss Austin and I'm going to be doing the lesson 21 practice problems. Here we go. The triangles here are each obtained by applying rigid motions to triangle 1. Which triangles are translations of triangle 1? Explain how you know. So a translation is a slide. So it looks like I can get to 3, I get to 5, I could get to 7. Do we see a pattern here? Looks like I can get to all the odd numbered triangles with a translation. All the odd numbered triangles. Explain how you know. They can all be, I don't know if this is obtained by sliding. Sometimes you have to slide this way, sometimes you slide that way, or you could do a combo of both. Like here, I could go to get to 11, I could go over and then up. To get to 3, I could just go over. To get to 5, I could just go up. So all the odd number triangles, they can all be obtained by sliding left, right, or a combination of vertical and horizontal. Which triangles are not translations of triangle 1? Well, if all the odd numbers are, then these even numbers aren't. And you can tell because this right here, sort of this, I'll kind of make a little squiggly line. That part is up here. The only way to get that would be to maybe rotate it and then slide it to get that up there. So all the even numbered, you can also do that symbol. All the even numbered triangles are not. How can we tell? The bottom of number 1 is on top of all the even triangles. Number 2, the quadrilateral is a parallelogram. Find the measures of angles 1, 2, and 3. So they're telling me it's a parallelogram because we know this fact that when two lines are parallel, we know things about the angles that are formed. Miss Austin is looking for a ruler, but oh well. So, for example, these two sides are parallel because it's a parallelogram. And these two sides are parallel. So I'll put a single arrow here. And then on the top and the bottom, we have a double arrow. So there's lots of ways you can figure this out. I would look, right? If you focus your eyes on the top and bottom, those are two parallel lines being cut by this transversal. And I know that this one would be 80, right? That's outside of the parallelogram. But these two together, right, make a straight line. So 180 take away 80, so angle 1 has to be 100 degrees. And then what else could we do? We could look at, if I turn it, we could look at these two parallel lines being cut by this transversal. I know alternate interiors are congruent, so this is 80. And again, this is making a straight line. So 3 has to be 100. Angle 3 has to be 100. And then, whoops, should have kept the paper turned. If I look at this, right? Look at these two parallel lines being cut by this transversal. These two are alternate interior. So 2 has to be 80. And it looks as if the opposite angles of a parallelogram are congruent. All right, number 3. In the figure shown, lines F and G are parallel. I'm going to zoom in here, put a little mark here. So now that I know there's a parallel, I know all kinds of information about pairs of angles. Select the angle that is congruent to 1. So is angle 2 the same as angle 1? No, those two make a 180. Nope. Angle 6, well, let's see. 1 would be the same as 4 because they're vertical, and 4 would be the same as 5 because those are alternate interior, not 6. Or you could think of it this way. 1 could be translated right here to 5, corresponding, and 5 and 6 add to 180. They're not the same. No. Angle 7. 1 is on the top left, 7's on the bottom. If you imagine, if I translate that just for a visual, if I translate that right here, boom, 1 is the same as 5, not 7. It's got to be 8. Is 1 the same as 8? Let's see. You could go 1 is the same as 5. We just did that, right? Because those are corresponding. I'll put a star here. 1 is the same as 5. And then 5 is the same as 8 because those are vertical. So yes. Number 4, angle BDE, see they marked it, is congruent to angle BAC. Name another pair of congruent angles. Explain how you know. Well, those two angles are in the same location. If you look at this cluster of 4, it's on the top right. If I extend this, there's 4 angles right here. It's in the same position. Those are called corresponding. Since corresponding angles are congruent, these two lines must be parallel. Right? That's the only way corresponding angles are congruent. Now I can go get another pair. And I'm going to take these two, right? If these two lines are parallel, which we said they are, then angle BED is the same as angle BCA, right? Because look, if you imagine, if I extend that out, that angle's on the top left of that cluster, and that angle right there is on the top left of that cluster of 4. So angle BED is congruent to angle BCA. How do I know? Lines M and N are parallel. Describe a transformation that could be used to show that corresponding angles are congruent. I'm going to use that figure up above on number 3. So corresponding angles is like this one right here. Number 1 is the same as this one right here, number 5. How could I transform 1 to 5? I could do a translation. If I slide this right here, look at this, along this directed line segment, boom, that just showed that 1 and 5 are congruent. So I could use a translation. Use a translation. Describe a transformation that could show that alternate interior angles are congruent. Okay, we didn't really look at that one, so let's just pick. Let's pick 4 and 5. Those are alternate interior. If I trace 4, how could I get 4 onto 5? I could do a, let's see, could I do a rotation of 180 using the center? Yep, I could do that one. If that one didn't seem so obvious, you could do a translation followed by a rotation here. Okay, but in one move, I could do a rotation around the midpoint of that segment. Boom. I'm a little off because I didn't. Okay, so I'm going to say rotation. All right. Number 6 says lines AD and EC meet at point B. Which of these must be true? Select all. A 180-degree clockwise rotation using center B takes D to A. Let's see. A 180-degree rotation using center B clockwise. There's 90. There's 180. D does not line up with A. The image of D after a 180-degree rotation using center B lies on ray BA. The image of D. So does this, when I do a rotation of 180, there's 90, 180, does it lie on BA? Yes, that's true. It was just like right there. So it's D prime. If a 180-degree rotation using center B takes C to E, then it also takes E to C. If a 180-degree rotation takes B to C, using center B, takes C to E, so I go 90, 180, yep. Would it also take, I didn't pay attention, look at the other side. Yep, E landed on C and C landed on E. Yes. Angle ABC, that's this one, is congruent to DBE. Yes, those are vertical angles. Angle ABE, we'll do a heart now so I can focus on it, is, oh, I did the wrong one. ABE is congruent to ABC. No, those two make a 180. All right, we're skipping number 7. Number 8 says, draw the image of figure ACTS after a clockwise rotation around point C using angle CTS. CTS, look at that, that's a 90 degree. And I'm going to clockwise around C by 90 degrees. So, boom. Then it says, and then a translation by directed line segment CT. So here to here. Boom. What do we got here? A double prime, S double prime, C double prime, T double prime. Triangle ABC is congruent to triangle A prime, B prime, C prime. Describe a sequence of rigid motions that can take ABC to A prime, B prime, C prime. Okay, so easiest way is to match a point to its image. I'm going to go B to B prime. So I'm going to translate along directed line segment B prime. And then I'm going to rotate on B clockwise. Ooh, I might have to do a reflection here. Actually, I'm going to rotate counterclockwise until A coincides with A prime. And then I'm going to reflect across BA. Boom. Okay, so what did I do? I translated along directed line segment. I did B, B prime. Then I rotated I went B to B prime, then I rotated on B counterclockwise and rotate on B counterclockwise until A coincides with A prime, and then reflect across BA. Line. You could call it segment or line. Okay? I hope that helped, and I'll see you soon.